Hi everyone, we're going to do 4 problems involving the second derivative of each function using the chain rule. The last 2 problems involve secant and sine, I think. So, yeah, the last two are trig functions. So, it's just basic. The first couple are pretty easy. We're just going to use the chain rule and take the derivative of x, so of f, and we're going to multiply the 3 and the 2 and get 6. X squared minus 1. 3 minus 1 is 2. Then you take the derivative of your inner function, which is 2x. And simplifying, we get 12x times x squared minus 1 squared. Okay, now we take the second derivative. So we're going to do the outer function first. Well, this one's going to have to deal with the product rule. So basically, I think what I want to do instead of doing that first is go ahead and FOIL this out because it'll make it easier. So to do that, I'm going to go ahead and do 12x. This will be x to the 4th minus 2x squared minus 1. And cleaning that up, you're going to get 12x to the 5th minus 24x cubed plus 12x. That way we don't have to use the product rule. And now let's take the second derivative. So that's going to be 60x to the 4th minus 72x squared plus 12x plus 12, sorry. This should have been a 12. So plus 12. Alright, and then what you should do, keep practicing. You notice that all of these terms can be divided by 12. So pull out the 12, and then you'll get 5x to the 4th minus, what is this, 6x squared plus 1. And now when we factor, we're going to get 5x squared minus 1 times x squared minus 1. And if you want to factor completely, see 5x squared minus 1. This one right here would be x minus 1 times x plus 1. Always practice your factoring skills because you're going to need them when we get into more complicated problems. Okay, this one, I'm going to go ahead and rewrite this as x minus 2 to the negative 1 and take my first derivative. So my first derivative is going to be negative 1 times x minus 2 to the negative 2. Alright, and then you multiply that by 1, which is going to be the same. So this whole thing is just going to equal negative x minus 2 to the negative 2. Now normally we'd clean this up, but since we take the second derivative, I'm going to leave it like that. So I'm going to multiply these two, and I get 2 times x minus 2 to negative 3 times the derivative of the inner function, which is 1 again. So that's going to simplify to 2 over x minus 2 cubed. Now we get into the trig functions. So this one is x squared. So when you take the derivative, we know the derivative of sine is cosine. So the first thing I want to do is take the derivative of sine. That's going to be cosine of x squared. Then you take the derivative of your inner function, which is 2x. I'm going to go ahead and put him in front. Alright. Now we've got to do this again, and we are going to have to use the product rule. So we're going to take the second derivative. So I'm going to write down my first function take the derivative of the second one. Derivative of the second one is going to be 2x negative sine of x squared. So take the derivative of cosine, that's negative x squared, and then you have to take the derivative of that. Then you add the second part. You're going to copy the second function down times the derivative of the first, which is just 2. And I'd like to put the 2 in front on this line. And then we can clean this up a little bit. This would be 2 times, I'm just going to put him in front, 2 times cosine x squared minus 2, and I'm taking care of this part now, minus 2 x squared sine of x squared. And the reason we rewrote it this way is because you don't want to lead with a negative. So I put him first, and when I distribute back I would get that, and when I distribute this guy I would get that back. And the last one is the secant one. This one's rather lengthy. So first we're going to write this as f of x equals secant of pi times x squared. And then I'm going to use the chain rule and take derivatives. So this is going to be 2 times my inner function, which is secant pi of x, and then you have to take the derivative of your outer function, or your inner function, and the derivative of secant is secant times tan. So that's going to be secant pi x times tan of pi x times x. And then you have to take the derivative of this portion. And derivative of that is just pi, and I'm going to put him out front. Okay, when you clean all this up, you're going to get, we got 2 of these. So I'm just going to write 2 pi secant of squared, which I'm going to just write it this way, and then tan of pi times x. Alright, now we take the second derivative, and that's the part that's a little lengthy. We're going to have to use the product rule. So the first thing I'm going to do is write down my first term. So we're going to write 2 pi squared times, let's see, let me do this again. The first line is going to be 2 pi times the derivative of this, which is going to be secant squared pi of x times pi. Then you write down your 2 pi times tan pi of x, and that's going to be times 2 pi secant squared pi x. Let me move it over. This is going to be times, I'm running out of room, so I know what I'm doing. I'm going to rewrite this down here. So this will be plus 2 pi tan pi of x times 2 pi secant squared pi x times tan of pi x. That's using your product rule and your chain rule. Now cleaning this up, let me move way over so I have room. You're going to get 2 pi squared secant, because we have two of these. Then we have secant to the 4th pi x. And then we have plus 4 pi squared, which is these two basically. Secant squared pi times x, tan squared pi of x. So I group my tans together, my secants together, and I have my 2 pi. So you might want to check that. And now what I'm going to do is factor out secant squared. So I'm going to factor out the 2 pi squared. And then if you do times secant squared, pi x. And what you're left with inside is secant squared pi x plus 2 times tan squared pi times x. Now, what I'm going to do, so I can have everything in terms of secant, I'm going to write my tan squared. We know that tan squared of x, sum x, equals secant squared of x minus, whoops, let me move it down here. So, again, this part, this tan squared, we know that tan squared of x equals secant squared of x minus 1. So that's what I'm going to write over here. I'm going to write 2 pi squared x, 2 pi squared secant squared pi times x. Then we have secant squared pi x plus 2, and we had tan. Well, now I'm going to write this as secant squared pi x minus 1. Alright? So what that's going to give you is when you distribute 2 pi squared secant squared pi x, then we're going to have secant squared pi x plus 2 secant squared pi x minus 2. And this should be a pi right here. Okay, and then simplifying those two, our final answer would be 2 pi squared secant squared, and then we have 3 of these. We have 1 here and 2 there. 3 times secant squared pi x minus 2. And that's all. Thank you. Have a nice day. Bye-bye.